Hello, calculus fans. Let's take this series where we're going to sum 1 over n to the fourth. N goes from 1 to infinity. Now we already know that this is convergent according to the p-series test. After all, p is equal to 4 and that's bigger than 1. So we're going to have a couple of questions here. First, we want to approximate this series by just using the first 8 terms, and we'll estimate the error involved in this approximation. And then the next question is, we want to ask how many terms do we need to add to ensure that the sum is accurate to within 10 to the minus 6. So to answer both a and b, we need to evaluate the integral from n to infinity of 1 over x to the fourth dx. This integral will come into play in both a and b. Alright, so the usual sort of thing, we rewrite it as a limit, write down an antiderivative, plug in the upper and lower limits, and we end up with 1 over 3n cubed. Okay, so we're going to use this in a moment. Now in part A, we're supposed to approximate the value of the series using 8 terms. So we just have to add up these 8 things. If you put this in your calculator, you end up with about 1.082. That's not really the important thing. The important thing is that according to the remainder estimate for the integral test, when we add up just 8 terms, the remainder, by using those 8 terms, is bounded above by the integral from 8 to infinity of 1 over x to the fourth dx. And we computed that. It's 1 over 3 times 8 cubed. And that's about 0.000651. That's actually really good. That's a very small error. But now let's see if we can ensure an even more accurate estimate. So we'll do that to within 10 to the minus 6. So what we need to do is find an n so that r sub n is less than 10 to the minus 6. We know that r sub n is less than the integral from n to infinity of 1 over x to the fourth dx. We've computed already that that integral is equal to 1 over 3n cubed. And we want 1 over 3n cubed to be smaller than 10 to the minus 6. If we do, then that makes r sub n smaller than 10 to the minus 6. Alright, so we just do a little bit of algebra to try to solve for n cubed. And we end up getting that n has to be bigger than or equal to 69.34. Remember that n has to be a whole number. So we're going to choose any value of n bigger than 70. And then we're guaranteed that s sub n will approximate the true value of the series, accurate to within 10 to the minus 6. Okay, that's all for now.